So hello everybody, my name is Neil. I'm going to talk about a picture right over here, and I'll talk about a project where we are trying to map the motility in the digestive tract. So in the beginning, let me talk about, hold on a second. Let me talk about what is digestion. So digestion is basically both a chemical and also mechanical process. And when we are talking about the motility, we are talking about the mechanical part of this process. And as you can see from here, you can see about AX making sausage. So after you have your food inside your digestive tract, your digestion is going to grind, process, and then transfer it downward. Well, however, in some situations, when this kind of motion is disrupted and you and your loved ones will feel unwell, it could be scenarios like the food is not coming out, which is we call constipation, or food is coming out in the wrong direction, which is called reflux. And so this is not, yeah. So this is not trivial because especially for patients who are having cancers or who are having cancer therapy, those kind of symptoms are very, very common. And so in the clinics, what the physicians are trying to do at here is to use something called manometry. That is basically a catheter of 1 feet long with an array of pressure sensors, and you can insert inside the esophagus and then try to get us an insight of what the motility is in the esophagus. And what we are saying here, if the state of art can only do for the esophagus, what if we build a system that can map the entire GI tract, digestive tract? And so one critical challenge we have to solve at here is to find a material that can transfer the signal from pressure into the electrical signals. And we have been trying to synthesize this material for a long while. But we see a lot of issues like the adhesion with the electrode and also the sensitivities. So long thing short, it's not working very well. And then someday miracle happened. Just like one day, when I was just trying to clean my bench, I was just about to throw some of those kind of foams. And one undergrad student was talking with me, and he said, you know, Neil, actually those kind of foams is actually conductive. And that is because if you are going to buy a piece of very expensive electronic device, and you want to rub it around with some foam that has some level of conductivity, so you can discharge electrons. If you have the electrons accumulating in your device, it could cause severe damage. And so if you're going to see some sort of like pressure applied on this foam, it could have some sort of changes of the electrical reduction. And then we start to find out the solution, and here is the solution. So we screen many different foams, and we realized for particularly this foam, it has the best electrical and mechanical performance. And what you are looking at here is looking at the skeleton of this foam, and the electrons would flow through those skeletons. And if you're going to compress it, you are going to create more connection points inside its structure, and electrons will have more pathways, and you are going to see the reduction of electrical resistance. So by doing that, we are now building a one-way relationship between the pressure and also the electrical resistance. And we are able to build our device, and we are able to conduct animal studies. And now we have a device that can map the motility everywhere in the GI tract, which is kind of very interesting. And so finally, I want to thank Professor Traverso for supervising me. I want to thank another facility core, and I want to appreciate anybody and everybody who has been working with me. Thank you so much.